Chapter 9.6, Counting Principles. So we're going to solve simple counting problems, use a fundamental counting principle to solve counting problems, use permutations and combinations to solve counting problems as well. Example 1, we're going to select pairs of numbers at random. So you place 8 pieces of paper numbered 1 to 8 in a box. You draw one piece of paper at random from the box, record its number, and replace the paper in the box. Then you draw a second piece of paper at random from the box and record its number. Finally, you add the two numbers. How many different ways can you obtain a sum of 12? So let's talk about first, you have, what is your first draw, and then you have a second draw. And so we're looking at a sum of 12. So the numbers that we have are 1, 2, 3, 4, 5, 6, 7, and 8. And so let's start with 8 first of all. So say we drew 8 first, what must we get in order to get 12? Well, we have to get 4. Then if we draw 7, we have to get a 5. And then 6, we need a 6 again. And that works because we put the paper in and draw it out again. So 6. And then after 6, we can draw 5. And then we'd need a 7. And then we would draw 4. And then you would draw 8. So these are the different ways that you can obtain a sum of 12. There are 1, 2, 3, 4, 5 ways that you can draw 12. So try this next example here. How many different ways can you obtain a sum of 14? So you can have 3 ways that you can obtain 14, the sum of 14. So with the same exact numbers, the first draw is 8, then you have to draw 6, 7, and 7, and then 6 and 8. Now let's change it a little bit. In example 2, you still have that 8 pieces of paper numbered 1 through 8 in the box. You draw one piece of paper at random from the box, record its number, and you do not replace the paper in the box. Then you draw a second piece of paper at random from the box and record its number. Finally, you add the two numbers. How many ways can you obtain a sum of 12? So again, let's do our first draw and our second draw. We want to get 12. So we can do 8 and 4, 7 and 5, but we can't draw 6, right? Because we can't draw another 6 once we draw it out. So then next we could have a 5 and a 7, then a 4, and an 8, and those are all sums of 12. So how many ways can we obtain a sum of 12? There are only 4 ways to obtain a sum of 12 when we do not replace the paper in the box. So try example 2. How many different ways can you obtain a sum of 14 doing the same thing where you do not replace the paper in the box? So if you don't replace, there are only 2 ways that you can obtain a sum of 14. So notice the difference between the counting problems in example 1 and 2. The random selection 1 occurs with replacement, whereas the random selection example 2 occurs without replacement, which eliminates the possibility of choosing 2 6s. So let's take a look at the fundamental counting principle. Let E1 be 2 events, and E1 and E2 be 2 events. The first event, E1, can occur in M1 ways. After E1 has occurred, E2 can occur in M2 different ways. The number of ways the 2 events can occur is M1 times M2. And then the fundamental counting principle can be extended to 3 or more events. For example, the number of ways that 3 events, E1, E2, and E3 can occur is M1 times M2 times M3. So let's take a look at this example here. How many different pairs of letters from the English alphabet are possible? So we're talking about pairs. So 1, 2. So how many letters are there in the alphabet? Well, there are 26, and then there are 26, right? So that is the number of different pairs that we could have, 26 times 26, which equals 676 pairs. So try this out. The combination lock will open when you select the right choice of 3 numbers from 1 to 30, inclusive. How many different lock combinations are possible? Now it's saying you can repeat numbers, so try this one out. So if you tried this, you should have gotten 30 times 30 times 30, which is 27,000 combinations. Pretty crazy. Example 4. Telephone numbers in the United States have 10 digits. The first 3 digits are the area code, and then the next 7 digits are the local telephone number. how many different telephone numbers are possible within each area code? So note that a local telephone number cannot begin with a 0 or 1. So we know with our phone numbers, we have the area code first, and that's 3 digits. Then the telephone number is the next 7 digits. Okay, telephone number. So it's saying how many different telephone numbers occur within each area code. So it doesn't matter what the area code is, so we can just ignore that for now. But the telephone number, so we can't have 0 or 1. So let's list the numbers we can have, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Those are the numbers you can press on your telephone. And so for the first position, we cannot have 0 or 1. So how many choices do we have? 1, 2, 3, 4, 5, 6, 7, 8. We only have 8 choices for the first number. Now for the second number, we can have any of those numbers. 10, so we have 10 choices, and 10, 10, 10, and 10 for every single choice. So we're looking at 8 times 10 that many times, or 10 to the 1, 2, 3, 4, 5, 6, 10 to the 6th power, just to make it a little easier to write out. So when you multiply this out, if you need to multiply it out, you have 8 million different telephone numbers within each area code. So try this example. A product catalog number is made up of one letter from the English alphabet followed by a 5-digit number. How many different catalog numbers are possible? So trying this out, the first digit or first place is the letter in the alphabet. There are 26 letters in the alphabet. And then it says 5-digit number. So again, you have 10 choices for each position there. It's 26 times 10 to the 5th power, or 2,600,000 choices.